Okay, so let's go over what's going to be in your final notebook. You know, it would be sweet to be able to copy paste these things into your notebooks, huh? But not all of us have that ability. That's why I said submit it on your own. I mean, submit this as a file by itself. But let's just say that we could do that. Oh, look at this, huh? I'll show you're gonna see something like this in a minute. Let me get rid of that. And it's clever of me, huh? I created PowerPoint slides that look like your notebook. All right, so let's see how this would look. And so you print this, and then you cut it out with scissors, and then you paste it in here. Now we just want it as a pic. Ooh, it has no background. Why not? No. Well, that stinks. And oh, I know what to do. Let me pause this for a minute. Alright, let's see if this will work. And it's not super critical for you guys, but just something to learn. So if we make the fill white, yep, that didn't make any difference here. And now we copy this, and now we go here. Nice. Keep source formatting. And let's see, so at the oh, no, that's not good. Well, again, it doesn't matter. Let's just make it a picture. All right, then we printed it, and we played with how big it looks. You can see how I resized this. You can just, the clever thing to do is copy paste this. Here, I'll show you. In fact, I should show you how to do that if you're interested. So you open up a word processing document, and then let's see if it's still there. Paste it in. Oops, nope, we want a picture. And there it is. So now oh yeah, because I copied this one. But let's say if I copied from here, and then I go here to paste it in. Paste it as a picture. Oh, still came out right. Okay, but let's just say, for example, it was too big, right? So instead of monkeying around with it, printing it and changing it, this way you can know that it's going to fit on a page, and your notebook pages, your logbook pages are bigger. So then you would copy paste from there. Copy. Or print it, right? Then cut it out, and then you'll know it'll fit in there. Okay, so if you don't have the ability to do that, to paste this in, let's see. Pause. See, if I wasn't stuck here at home, I would just ask you guys to send me these things and print them for you. You know, you create a document like this with your tables, you email it to me, or you come to my office or something like that, and I would just print them out for you. So then what I would tell you is draw a little placeholder here, and then make believe it's there while you're writing notes, right? Okay, so this would be the analysis section. And so let's see. So you had your raw data table. Remember, your raw data table would be up above, and now you've and I always like to have a fresh page when I do this. And so this analysis, and so we have our table 1. All right, so you say, look, in table 1, we let's see. First of all, so okay, wait a minute, no erasing, right? So I goofed. We entered all data into a spreadsheet. Okay. Table 1. So you say, look, there's the mass. Note it, and you don't have to get into it too deeply, because you say, look, the column 1 is the different materials. Column 2, the different instruments. I don't know. It seems like that's pretty obvious up there. Yeah. So right. So I would just say, because none of those are calculated values, right? So I'm gonna cheat here, because I decided to change my mind. Okay, so you say, let's see, 1, 2, 3, 4, 5, 6, 7, 8. The first 8 columns are the data collected. And then there you go. So column 9 is the volume, which we did as volume of a cylinder is equal to pi r squared. So remember before, blah blah blah. So we decided to use volume equals to pi over 4 d times L. Okay. Then now you explain the column 10. That's the plus minus volume. Whoops. And this is where you write out the oh, what the heck's that doing on there? Something's up with the sensitivity of my. What is that? Hold on, see if I can bring it down. Well, I tried a few things. I just turned the tablet on and off and on, and it worked. Okay, so this is where you say, okay, we use this formula for the plus minus, the sigma on the volume equals the volume, and you remember that. And then the column 10, column 11, let's see, that's the plus minus is column 11. No, that's column 10 is plus minus. So column 11 is the density. And, you know, let's see, density equals the mass over the volume. And then column 12 is the plus minus of the density. And that sigma dense. And this was, yeah, that's fairly straightforward, right? And because it's just 2 terms, so you have that already. Okay. Then what's next? So if you can't print, you can just like sort of draw a little box here, and say refer to the spreadsheet, please. Okay, then we need a new page, and then now we have our table 2. Oh my goodness gracious, this is the data table. Okay, so hold on. Right, data table is table 1. So of course this is table 2. Okay, and right, so in principle you would have written down your values in table 1, and you would have explained about these decimal places and such. And we do need to explain that a little bit. Okay, hold on. All right, so let's do our little trick here. And this is we need to put a background on it, which only, I guess, no, I mean, if you copy paste it into Word, no, you probably wouldn't need to do this, but I need to do it. Okay, so no picture, we just wanted a picture for, what is that, was text, picture, just picture. Okay, so there's our table 1. Now you guys have it handwritten. And so give me a minute here to think. So right, what you have to do in the analysis, if you don't necessarily have to put this here, but you have to explain what is average is the measurement 1 plus measurement 2 divided by the number of measurements, right? And the spread is, and for us, we don't really know much about it, so the spread is the standard deviation from Excel and this, we're saying this is the plus minus on our average. That's good enough. Okay, very good. Yeah, so the if you hand wrote the table, you can just fill in these numbers and then just explain what average and spread is. Okay, so we've done table 2, and now we go to table 3. Well, there's the way we've set it up, there's a few of them. So that's table 2. And so well, let's be clever here, and we're going to all give them a white background. In fact, I am also going to pause this for a minute. Oh, by the way, don't forget date, time, initials. So let's see, I'm doing this on Friday, so I always like to use 2-0, this format here, so everybody knows that of course there's no month. Well, there's 12. You wouldn't have a month 19. but there is a 13, right? So this way everybody knows date, and I see here this is 14/27. There's my initials. Okay, so we've got these tables, and oh yeah, this is analysis still. Oh no, wait a minute, give me a minute. Yeah, analysis. Well, this is more like a result now, I suppose. Let me think about this for a minute. You know, it doesn't really matter. You know, I just let students get stressed out because they give them a format and they think they have to have everything all the time. And in fact, this is our results, right? At the end of the day, this is what we were searching for. Okay, so you say, look, the three tables, compare our measurements with the different instruments to the actual value of density. So the tables, we could call them 3A, 3B, 3C. Also, don't forget the, let's see, what was it? Well, it doesn't work well here. Putting in something like this. Suppose we should have left a little extra white space, right? Okay, meaning in the table itself. The tables compare our measurements with accepted values. And then you say, okay, so discrepancy is the absolute value of accepted minus measured, since we're using absolute value, doesn't matter the order. And then the relative uncertainty is the plus minus measure divided by measured times 100%. And our figure of merit is defined as the yeah, we have to give me a minute here, is the where is density? Density measured. So it's the accepted minus measured without any give me, I think that's wrong. Let me double check. Yep, it's you're comparing the discrepancies and the plus minus. And so I'm just going to erase this because I just to save time and space here. So this is the what is it? Yeah, the uncertainty minus the discrepancy. And then now you have the discussion about that I outlined in the previous video. You write that up. Oh wait, excuse me. That's just defining it. Okay, so other results. All right. So keep going with the results. Then so we can see that first of all, notice the percent errors, right? So we see that percent let's think about this. It's ruler. Oh, I see, right. Put percent uncertainty for the ruler is greater than the calipers, which is greater than the micrometer. So the micrometer gets you the best measurements. Micrometer is the most precise, the best number of decimal places, which is what we would expect. And now you go into the discussion of how the figure of merit, which is important, about being greater than 0 or less than 0, and it's stuff that was discussed in the last one, last video, the video about table 3. And that is okay. Let's double check. I think that covers everything that the manual would have asked for anyway. In fact, I don't even care what's in the rest of the manual, because it's basically the same. I've just made it more clear, simpler steps, and kind of justified the steps in the manual instead of just simply giving you some unknown recipe. Right, and that's it. And then remember, there's no report, and you're just going to write all this up in your logbook. And again, don't forget, I haven't been doing it, date, time, initials, and you probably want the biggest complaint, other than date, time, initials, I always tell students you need to add, I'm being very quick here, right? You really need a few more words, you need to explain things better than this. I'm just being real fast so the video isn't too long, okay? And then we'll go from there. So don't stress. All we're trying to do is get going, and the only way we're going to be able to improve is to try it, right? And then look at what we did, and then I tell you what you could have done better. The biggest thing I want to see is effort, which would be, of course, one big thing about effort is trying to write more notes, be more wordier, that I guess, and the date, time, initials, if you keep leaving that off, that just kind of bugs me, right? That's things that we need to focus on. All right. Don't stress.